Today's lesson is raising a power to a power. This is where you have an exponent not just attached to a number or a variable, but then you have this second repetition happening up here. So it's like saying, I have x to the third, x to the third, x to the third, x to the third. I've got 4 x to the thirds. So we say then that we have x to the 12. So what you do is you multiply the exponents. Looks like someone borrowed that pen. Bummer. All right. So then, if I was here, I would just multiply these two and get n to the 15th. Now when you're doing this, you want to always try and, the way you can identify them is they're sharing the same base. So there's 2 exponents sort of attached to this y. That's how you can kind of tell you need to multiply them. If I had y to the 5th and y to the negative 2nd, those two would get added. They each have their own base that they're attached to. So here I would say I have y to the negative 10th. Because that's negative, it has to move down and become divide. I'm dividing, so then I get 1 over y to the 10th. Now here, when you have more than one thing, well, more than one number or variable inside your parentheses like this, they're both affected by that 5. You imagine that this is being repeated 5 times out. So you'd say there's a 3 to the 5th because that's being repeated out 5 times. And there's an x to the 10th, like that. I have to think of 3 to the 5th, I think. Yeah, 243. And then I've got x to the 10th after that. And you want to simplify completely when the directions say simplify. Sometimes they'll say like rewrite it with the same base. Then you would just write that. But when it says simplify, you do that. All right, so then this one would be 5 to the 3rd and y to the 12th, giving you 125 y to the 12th. Here you have a couple of them going on. You have your 3 out here applying to everything individually in here. So you would have 2 to the 3rd, a to the 3rd, and b to the 3rd. You would have 5 squared and a to the negative 6th. And then you're going to just sort of throw everything together. These are going to go together. And these are going to go together. It's not really combining like terms, but in my head that's kind of what I think of it as. So then this becomes 8 times 25. A to the negative 3rd then, because I would add the 3 and the negative 6 together, and then b to the 3rd. And then from there I would have 200 over, because that needs to now become division of, so a to the 3rd and b to the 3rd, like that. And if this part where I'm saying like this is telling me it's the opposite of the exponent of 3, which an exponent is multiply by that thing 3 times out, so then this is saying divide by that thing 3 times out. You can also just kind of remember if it's negative, it needs to cross the fraction line and change its sign. Now scientific notation, kind of the same thing. You got to really watch your negative exponents because they create that division or create that fraction. The scientific notation doesn't deal in fractions, it deals with decimals only. So I'm going to bring this 2 into this 2, so I would have 2 squared times 10 to the 6th, that becomes 4 times 10 to the 6th. Always watch that number there. It needs to be greater than or equal to 1, and it needs to be less than 10, so 9.9 repeating, so to speak. All right, so then this one I would have 2.3 to the 3rd times 10 to the negative 24th. I'm going to type in 2.3 to the 3rd, and I get 12.167 times 10 to the negative 24th. Now, That number is too big, so I have to move my decimal one place to the left. If you move your decimal to the left, you end up needing to add here, because you're making one more slide in your list. So then you would have 1.2167, or in this case 1 less, times 10 to the negative 23rd. Here you would have 4 to the 4th power times 10 to the 20th. 256. I think I need to double check myself. I'm feeling confident. Okay. Times 10 to the 20th. Now this one is 2 slides to the left. So over here I'm going to add 2 to the exponent. I'm going to get 2.56 times 10 to the 22nd. You'll see one of these when you take your quiz, where you're bringing this negative 2 into this 2, giving you 2 to the negative 2nd times 10 to the negative 6. Now 2 to the negative 2nd, you're over here probably thinking, okay, well that would be 1 over 2 squared. That would be 1/4, which is exactly right if I was doing a problem like this one. However, this is scientific notation. I need a decimal value. So I have to adjust this now and go, all right, that needs to be written as 0.25 then, the decimal equivalent of that fraction, times 10 to the negative 6. So in this case, I'm going to be moving 1 to the right. Then I will subtract from my exponent. And when you subtract, just think your regular rules like that becomes a negative 7. So you get 2.5 times 10 to the negative 7. And there's scientific notation to a power. The word problems essentially are having you multiply scientific notation or multiply things that are already written in exponent notation. So here we have the length of a square is 2 times 10 to the 5th. Well, it's a square and it's asking for the area. So the area of a square is the side length squared. So I'm going to take that side length of 2 times 10 to the 5th and I'm going to square it. So we'll have A equals 4, or 2 squared, times 10 to the 10th. And then it says to leave your answer in scientific notation, so then you would write centimeters squared. And just keep in mind that volume is always the unit cubed, because it's 3-dimensional space. And the area is always whatever your unit is squared, because it's 2-dimensional space. All right. This one says we have the radius of a cylinder is 7.8 times 10 to the negative 4th, so that's here. The height is 3.4 times 10 to the negative 2nd, so there's my radius squared, my height, I'm going to throw pi in here, equals volume. That says what is the volume? Keep your answer in scientific notation. Now, I don't switch out pi for 3.14. I leave it sitting there like a variable. Like if I was solving along and I didn't know the value of x, I would just keep it sitting there as x. So that's how I treat that. So I'm going to leave that there. And I'm going to take 7.8 squared. Oops. And I get 60.84 times 10 to the negative 8. I still have 3.4 times 10 to the negative 2nd. So all I did here was really essentially square that 7.8. Now this is just a string, like this is a single number right here, and so is this. This is one really small number value, and this is one really small value. It's a very tiny object that we're talking about here. But I'm going to break these apart because There's the associative property and commutative that tell me I can reorganize this because it's all just a pile of multiplication. As long as I keep these exponents stuck there and don't try to mix them up at all. Don't let them move around. So this becomes pi, and then I'm going to put 60.84 times 3.4, and 10 to the negative 8th, and 10 to the negative 2nd. And you can use dots for times too. There's no x's in this, so I keep the time sign just because it seems to be like the notation, you know. All right, so then I'm going to take 60.84 times 3.4. I'll keep that in parentheses, I think, for a hot minute. And then times 10 to the negative 10th. Now, like I said, I'm going to keep pi just sort of hanging out with this problem like a variable. So I'm going to move it because it's going to look, I'm going to need it, this number to act like a coefficient, or the scientific notation too. So pi is going to move its way down here to the n. I also need to slide this decimal 2 places to the left. And if you remember, and this is on every page of your notes, I believe, just to make it easier for you, that when you move to the left, you add to your exponent. So then I would add 2 to negative 10, making it negative 8. So then this becomes 2.06856 times 10 to the negative 8 pi. And then I'd say units cubed, or in this case, meters cubed. Now, some people will tell you never to round scientific notation. I think it's more of an opinion. Every time you round, you know, your answer is slightly inaccurate. So I kind of have mentally a line of like, I'm not going to, if it's a repeating one, or if it, you know, goes beyond 4 or 5 spots, I might round something like that. But like I said, you might need to just double check with your teachers, because maybe in science you wouldn't want to round that, but, you know, in math, we're trying to get a roundabout answer, and it might be okay. It really depends. If you're going to do other math with that, say take this number and then multiply it again, or throw it into another formula, you definitely don't want to round, because then you get something called rounding error. The more you work with a rounded number, the more that little tiny error gets magnified in the problem. Okay, that's it for 7-4.